Right. I have a computer science exam in 2 weeks, and I don't want to make my parents more mad, seeing that I've already done badly in some of the other exams. If I don't get above, I don't know, 80 or 90%, well, I'm gonna be really, really sad, because my internet's probably be just busted. Mind you, I have revised most things for the exam. I just need to finish off some topics. Time to check what topics I need to revise. Let's start off with RAM.
RAM, to start off with, stands for Random Access Memory, which means that it's memory that can be accessed randomly, as said in the name. This also means that RAM is a lot faster than other types of memory storage. RAM is also a volatile memory, which means that data stored in it will be lost forever when the computer powers off.
Thanks, Michael, but where in a computer would I actually find RAM?
Seriously, you should have revised earlier, idiot.
2 words. Internet gone.
Yeah, well, I'm telling you, you should have revised earlier.
Please.
Fine. RAM is found at the RAM storage slot in the motherboard of a computer. Before you ask, the motherboard of a computer is the board which holds many, if not all, of the components in place. For example, the CPU socket, the power connector, the ports, and most importantly, the RAM.
Okay, hold up. Right. Okay, got it. One final thing. How does RAM actually work?
I really shouldn't be helping you, but here goes. RAM stores a series of addresses, each of which is a piece of data. When the CPU sends an address to the RAM, then turns on the enable wire which goes from the RAM to the CPU, RAM will send whatever piece of data that address contains. This function is used to retrieve a program when the CPU is required to do so. When the CPU sends an address and a piece of data to the RAM and then switches on the set wire, the RAM will override whatever data is at that address and save the new data that the CPU sent it onto the address. These pieces of data can contain many things such as instructions, addresses, numbers and letters. Come to think of it, actually, those are the only things they can be. The pieces of data used are as follows. Instructions are things that the RAM tells the CPU to do, and we'll get more into detail on that later. Some addresses inside RAM can just be addresses. For example, when the CPU wants to output something to an output device, it will need the address of the output device to output something to that device. Numbers are just used for general arithmetic by the CPU, which we'll also get into later. Letters can be used if you want to output some text to an output device like a monitor. Instructions can be used to make the CPU do specific things. For example, they could be used to make the CPU add two numbers together, or it could be used to make the CPU compare two numbers and act upon the comparison. The following are instructions that can be in RAM addresses. The load instruction. This loads something from RAM into the CPU. The add instruction. This is used to add numbers together. The store instruction. This saves a number in the CPU to RAM. The compare instruction. This compares numbers in the RAM. The jump instruction. This jumps to another address in the RAM. The jump if instruction. This jumps to another address in the RAM only if a certain condition is met. The out instruction. This outputs data to an output device. And the in instruction. This takes an input from an input device. These instructions can be stringed together with addresses, numbers, and letters to do certain things. Here's an example if you don't quite get that.
Yeah, definitely need an example.
Be grateful, jeez. Okay, so here, there is an input instruction, then an address, which loads a number from the input device. Then there is another input instruction followed by the same address, which loads another number from the input device. These numbers compare by a compare function that follows it. Then the jump if function that follows it will jump to another address if the first number is greater than the second number. If the first number is greater than the second number, the jump if instruction will jump to an out instruction, followed by an address and the letter Y, which will output the letter Y to the output device. If not, the RAM will ignore the jump if instruction and output N to the same output device as before. This is why the random access memory is useful, because the jump if instruction can be used to jump to a random address in the RAM.
Please tell me that's it. I'm already half asleep.
Thanks for being appreciative of me helping you, but yeah, that's it. That's basically all you need to know about RAM for the test. I think.
There's one more thing, Michael. Thanks a lot, by the way, just mentioning that. But there's one more thing. What would a question about RAM be like in an exam paper for computer science?
I think this could be an exam question about RAM. How does a computer run programs like Microsoft Word? You would say that RAM enables computers to run programs such as Word because RAM is volatile, meaning any memory it holds will be deleted when the computer shuts down.